Hello, I'm here again with another question. Now, what's the time? 3:30. 3:30. I'm still doing these questions for you. Dedication, man. Dedication. Dedication. I want you to be dedicated about this whole process as well, okay? So we've got only how many more months? Maybe 4 months. July, August, September, October. Yes, now this is the time for you to wake up and do work. All right, let's look at the question. What question? Question three. Now, this is a bit of a question that we haven't discussed yet in classes, but we can always learn. Now, the question is asking you whether this molecule, whether this given molecule or enantiomer or not. Now, the thing is this: you don't know what enantiomer is because we haven't discussed those things. Enantiomers in classes, have we? No. Okay, what is the enantiomer? It comes under stereoisomerism or stereoisomers under optical isomers. So if you want to know whether something is enantiomer or not, it is easy. You can identify enantiomer looking. You can identify enantiomer by looking at. What? My words are not coming out. Okay, you can identify enantiomer by identifying a chiral carbon. What is a chiral carbon? It's a carbon with four different groups. When four different groups attach to a carbon, four totally different structure-wise. Yeah, it is called a chiral carbon. Okay. Now, as an example, I'll show it to you. This carbon is chiral. Why? There are four different groups attached to it. Look, this is one group, another group, and this is the other. Look, so there are four chemically different environments. Oh no, four different groups attached to it. So this is a chiral carbon. Now, this molecule has got a chiral carbon, and this is also a chiral carbon. Why? This group, they are totally different to each other. You see that? So these groups are different. So in other words, a carbon which has been attached by four different groups, we call it a chiral carbon. Now this molecule has got, as a matter of fact, two chiral carbon. This carbon is chiral, this carbon is chiral. So if you have a molecule with at least one chiral carbon, you can call that molecule you can call that molecule an enantiomer. All right, man, the words are coming a bit slowly. It's 3:30. Sorry about that. So this is chiral, this is chiral. Therefore, this molecule can exist as enantiomers. We'll talk about that in great detail later. Okay. Now, what's the answer? Deduce whether the following molecule would have enantiomer. Answer is yes. Molecule will have enantiomer because there are two chiral centers or chiral carbons. The answer is there are two chiral carbons. What are those carbons? This is the first one, second one, and third one. So there are two chiral carbons. Second and third carbons are chiral. Therefore, this molecule can have enantiomer. That's the answer. All right. So we will talk about this stuff in details later. So don't worry. Okay. Take it easy. No stress. All right. Let's look at the question 4. This can be done without any problem. They want us to what? Arrange these molecules in order of viscosity. What is viscosity? It's a liquid. It's property of liquids to its resistance to flow, right? Flowing means when you pour something, you're like pouring something. Pouring, that is, sometimes you can pour certain things quite easily, like water. Then if it is honey, they pour bit slowly. It's more viscous. It's all about the intermolecular forces. More stronger the intermolecular forces, molecules are not going to go past easily. Very hard, strongly attached to each other. If they have weaker intermolecular forces, boom, they go just fast on top of each other. So it's less viscous, yeah? So stronger the intermolecular forces, higher the viscosity is. That's all you need to know. Now in this case, they are all alkane, aren't they? Yes, alkane. So arrange the viscosity. What is least viscous? Oh, then again, you have to talk about the intermolecular forces between these molecules. Which one will have the strongest intermolecular forces? You know, the pentane. Why? Bigger the or larger the molecule, more the dispersion forces, because they are all non-polar molecules. So only intermolecular forces uh, they can have are what? Only intermolecular forces they can have between those molecules are dispersion forces. Now, in this case, bigger the molecule, more the dispersion forces. More the dispersion forces mean stronger the intermolecular attraction. Stronger attractions means more viscous. All right? Pretty straightforward. Okay, so explain your answer. First, put them, let's arrange them in order. Least viscous, this one. Viscosity, arrange the mode. Okay, in order to less than C3H8, less than C4H10, very easy question. Less than C5H2, this is the 11. That's the order. Explain your answer. You can say as the size increases, size of the molecule increases. How many marks is that? 2 marks. So number of dispersion forces forces of the of these non-polar molecule increases. Non-polar molecules increases, right? So non-polar molecules increases. That's all. Hence, molecules are held together more strongly. Hence, you need to say that molecules are held together. Molecules are held together more strongly. More strongly. And more strongly. Hence, more resistance. They show more resistance. They show more resistance to flow. All right, done and dusted. Question C. Let's do question C, man. Yo, easy question. Easy question. Why? They want us to do combustion. Why are you asking this stupid question, man? Why? Why are you wasting my time asking this stupid question? Huh? This question, this sack? No, bad sack, bad sack. All right. Write a balanced chemical liquid combustion of butane. But if you don't know what butane is, man, you need to start revising organic chemistry. What's the butane? Look at the data booklet. Is it a gas or a liquid? Then you need to find the states. Yeah, I think it's a gas. Complete combustion. You know what? Yo, this is ridiculous, man. H2O. Complete combustion of the methane. Okay, why the chemical equation of complete combustion of methane? So it's a gas. This is a gas. This is a gas. Okay, this could be a gas or liquid. I don't think it's a big issue here. Now, what? 6.5 O2. Yeah, 6.5 O2. 6.5 O2. So the question says no mark deduced for incorrect state. So the state doesn't really matter. Balance it 4 here, 5 here, 5, 8, 13, 4, 8, 5, 13, 12.5. So if you're not happy with that, multiply it by 2. Who cares? All right, that's done. Question 2, no, 4 and 5. Oh no, 3 and 4. 3 and 4 is done. Alrighty, we are going to come up with what is the next question? Reaction pathway. That's going to be interesting. So let's finish those questions too quickly as well. I'll talk to you soon.